Hello friends, in continuation with the last lecture, now we'll try to understand that the next transducer, the one of the type is strain gauges. Actually, it is a passive device which converts the mechanical elongation or the displacement produced due to the application of the force into the corresponding changes in resistance or the inductance and the capacitance one. Okay, so whenever the displacement is occurring due to the force application into the corresponding change, so that will be converted into the corresponding changes happening in the or it will be measured in terms of the change in the resistance, change in the inductance, and change in its capacitance. What is the working principle of the strain gauges? Is something like it works on the principle of the electrical conductance and its dependence on the conductor's geometry. So the geometry of the conductor plays a very important role in the working principle of such a type of the displacement transducer, that is the strain gauges. Whenever the conductor is stretched or we apply stretched means so we apply the force and that force has to be applied within the elastic limit and it does not break but gets narrower and the longer one. When we try to just apply the force on a conductor or as just consider the single wire, and if we just try to apply the weight on the one side, and because of the application of that weight obviously to exerts mg amount of the force in the downward direction, and obviously because of that force that conductor gets stretched. Okay, and why within the elastic limits we have to apply the force? Because it should not get breakdown. Okay, or the plastic deformation into that material, it does not break but gets a narrow, and so because of the application of the force it that wire or the conductor gets narrower and the longer one, that elongation happens within that conductor. Similarly, when we try to compress instead of the stretching that material, if we apply the force in the opposite direction and if you compress the conductor, it gets a shorter and the broader one, so the its length gets contracted and the width increases, so it gets broader, ultimately changing in the resistance. So that will also cause to change the resistance of that conductor. Basically, it is used to measure the strain in the workpiece. If the metal is subjected to a tensile stress is nothing but the application of the force along the its length. Okay, tensile if metal is subject to the tensile stress, the metal length will increase and thus increases the electrical resistance. Similarly, on a compression, the length will decrease, but the width also will increase. Okay, so on compression, what happens that the length decreases, but the width will increase in this case. If both the stresses are limited within the elastic limits, that is, so Hooke's law gives us the elastic limit, that is within the elastic limit, stress is directly proportional to the strain. So this both the stresses are limited within the elastic limits. The metal conductor can be used to measure the amount of the force given to produce the stress through changes in the resistance. Here, the resistance of a strained wire is more than that of the unstrained wire of the same dimension. See, you do remember that the resistance of the strained wire is more than that of the unstrained wire of the same dimension. Obviously, the same material we must consider as well. So, compression or the expansion of a metal of a given dimension alters the resistance. Obviously, if suppose the material is compressed first and then if we try to expand it or the vice versa, then obviously it's of the particular given dimension, obviously it also alters the resistance of that material. So resistance of that wire or the metal is given by R is equal to rho L by A, where the rho is the resistivity of the material, L is the corresponding length of the wire, and A is the cross-sectional area of that particular wire. So change in the length, cross-sectional area of the wire alters the resistance. resistance. Now, the actually is a very important factor to decide the characteristic property of the particular strain gauge. So, the gauge factor. So, it is defined as the ratio of the fractional changes in the electrical resistance to the fractional changes in the length. So, it is defined as a gauge factor is equal to fractional changes in the resistance, the ratio of this with its original resistance divided by the fractional changes happening within the length, the delta L by L. So this is delta L by L is nothing but the strain is given as a represented with the epsilon. So delta R by R is there. So gauge factor is given by delta R by R by epsilon. Epsilon is a the strain. So the sensitivity of the strain gauge is described in terms of the characteristics. We call it as a strain gauge. So sensitivity of the material will be defined on the in terms of the characteristics is a gauge factor. Now there are various of the strain gauges are there. One of the type here we are going to understand or learn is the unbonded strain gauges. Okay, unbonded is not bound to the any kind of the material or any places which is there. So what is the working principle of the unbonded strain gauges? The strain gauges are not directly bonded onto the surface of the structure under the study, means they are not bonded directly onto the surface of the structure wherever is, hence they are termed as the unbonded strain gauges. What is the principle of the measurement? How we generally measure the strain using a unbonded type of the strain gauges? It has a frame and that consists of the stationary and the movable parts, means one of the part within this strain gauge is a fixed one, the stationary, and the another is moving with respect to it. Wire is located on both parts and is wrapped around the non-conductive posts. Okay, wire tension increases and decreases with changes in the pressure. When movable parts are displaced, this strains the wire and increases or the decreases the resistance of accordingly. The electronic circuitry converts that this resistance measurements into the pressure output. Now we can understand how it is represented, or the description of the unbonded type of the strain gauges here. See, there are two frames, one of them is fixed and the another one is the moving one. So the frame P and Q are carrying rigidly insulated pins are shown in this figure. Okay, so these are the insulated pins. Okay, 1, 2, 3 and 4, and the wire is just bonded on it. Unbonded strain wire is there also. Okay, and this is a fixer. The below that Q frame is a fixed one, and the P frame is allowed to move over here. So what we can say, the blue frame is fixed and the black is moving with respect to it. Now here we can apply the force on it, okay, in the downward direction. So what happens that unbonded strain gauges, that is a wire, that's some metallic wire is there, very thin one, and it is just tightly bound on this, and because of the application of the force it moves it moves it. So these frames can move relative with respect to each other and are held together by the spring loaded mechanism. So this is spring loaded mechanism. A fine wire resistance, that is of the sometimes metallic or the alloys also, nickel chromium, copper, nickel, iron alloys. Also strain gauges stretch around the insulated pins. Element is connected via a rod to diaphragm, which is used for sensing the pressure. Wire is tension to avoid bulking when they experience the compressive force. So the resistance wires are of the equal length. Resistance wires are of equal length here. The strain gauge is connected to a piston base. So the strain gauge is connected as a one of the resistance in the piston bridge, or the one of the arm in the piston bridge circuitry. Uh, when force is applied on the structure, okay, force is applied on the structure, and then what we can say, that the one of the frame will try to move relative with the one of the frame will try to move over the other one. Okay, the P moves relative to the Q. So due to this, the strain gauge is strained. Okay, strain gauge is strained, and the changes in the resistance are measured using the piston bridge. So this change in the resistance is calibrated, and it becomes a measure of the applied force. The unbonded meter wire gauges are used exclusively in transducer application that employ preloaded resistance wire connected in a piston bridge. So you can see from this figure as well. So this is a strain gauge is one of the arm in the piston bridge, R1, R2, R3, R4. So this is the external power supply, that is auxiliary power supply also we call it as. Okay, and it is given on the opposite side of this bridge circuitry, and remaining two junctions will be connected to have the output voltage will be developed across it. So whenever there is initially no any changes happening in the strain gauges, no load is applied, then obviously there is a no output will be, or no potential developed across the its bridge. But if suppose if there is this circuit or circuitry becomes imbalance, then when it will imbalance, when there is a generation of the strain when we apply the force on it, and this imbalance will generate the potential across it, and this will be measured in terms of its amount of the force application on it. Okay, so initially the resistance of the four arms including the strain gauge is normally equal with the resultant output voltage is 0. Now the application of the pressure produces a small displacement, and the displacement increases tension in the two wires and decreases in the other two wires. So the thereby increase the resistance of the two wires which are in tension, decreasing the resistance of the remaining two wires. This causes an imbalance of bridge production producing an output voltage which is proportional to the input displacement, and hence to the applied pressure. What are the applications of this type of the unbounded strain gauges? It is used in the place where the gauge is to be detached and used multiple times. Okay, gauge can be detached detached easily, and can be used multiple times. These gauges are used in force, pressure, and acceleration measurements. What is the advantages? The range is plus or minus mm, 0.15% strain. So this is the advantages of this type of the strain gauges. It's a very high accurate. Okay, it has a very high accuracy. And what is the limitations? The occupancy or its occupancy is a more one. It requires a more space to place the strain gauge. Thank you.